Hi, welcome back to the Chico Statistic lecturing series. And we're going to start a new unit today. And we're going to talk about random variables and distributions. This is an extremely important unit because a lot of the later lectures are based on this unit. So we're going to start to define the random variables. And then, we're going to talk about what is the probability distributions and what is the distribution function for the random variable. And then, in the later, we're going to talk about what are the distributions for the different random variables and how they related to each other. So that's why I said this is extremely very important units. And okay, so for this ones here, for this lecture, we're going to come out with 2 videos here. So the first video, of course, we're going to define a little bit about, we're going to talk about what is the random variables here, okay? And then we're also going to talk about what is the probability distributions, right? And after that, we're going to introduce a very important theory. We say, hey, if this random variable has this probability distribution, what are the characteristics or the conditions they need to have here. And we're going to take a look at the 3 examples here, 1, 2, 3, and we're going to stop here. Then our second video, we're going to talk about is what is the distribution function. And sometimes we call this the cumulative distribution function. And what is the relation for the distribution function to the probability distributions. So we're going to cover, we have, I think, 2 problems for the second video, so 2 examples to cover that. Okay, so now let's start, and I'm going to go to the whiteboard and let us start to define what is the random variables here. Okay. And okay, random variables here. So what is a random variable? I think if you know the algebra, so the random variable really is what? It's a functions here. You can define a functions, and this function will map. So that when you do an experiment, right? So when you start when you do an experiment, and this experiment, you're going to have a sample space, right? So you're going to have a sample space. Depends what type of the experiments you're doing. It's like previously we talked about, you can do the experiments like flip a coin and toss a die, or flip 2 coins, and all these are the experiment. Then for the experiment, you can define the sample space. So what is random variable? We say the random variable is a functions. Okay, so what that means is a function. That means for every elements, in the sample space, then I mapped it to a values here. That means for the every elements, I mapped it, and so I give them a numbers here. Okay, so this is a function, and you can define any type of random variables you like, right? So that means you can define the function for your experiment. So the random variable, typical, we use the capital letter. To represent the random variables. We use the RV, so it means the random variables here. And then we use the lower, so you can say the random variable x, we typically use x, y, z, w, da, da, da. Of course, you can use a, b, c, doesn't matter, all right? Then the lowercase, okay, so if you define a random variables, right? So if you say the random variable x, then the lowercase of the x is the value, right? So that's the is the value of that random variable. Okay, so we talk about this. So let's see what that means here, right? So let's say if, for examples here, I toss 3 coins. Okay, so if you toss 3 coins, right? So then your sample space is here going to be what? You're going to have a head, 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 tail, head, tail, head, tail, head, head. And then you're going to have, also you're going to have like a tail, tail, head, tail, 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 head, tail, and head, tail, tail, and the tail, 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 right? So that's what is the experiment you're doing. You toss 3 coins here. Okay, so after you toss 3 coins, I can define my random variable. Remember, the random variable is functions, right? So random variable is a function. So every elements in the sample space, you map to a values here. Okay, so now let's see here. I will say I can define the random variable x is equal to the numbers of head, right? So that means I'm going to define this random variable x here is the numbers of the head. Okay, so now let's take a look here. If I define this number of the head, so remember the random variable match every elements in the sample space to a value. So what is the first ones here? So this one is 3, right? Okay, so this is how many heads? 2 heads, 2 heads, 2 heads. So this is 1 head, 1 head, 1 head, and 0 head, right? So those numbers, the green numbers here, so that's the value of the random variable. So you can use the lowercase x here, right? So in here, as you can see, the lowercase of here will be what is 0, 1, 2, 3. So that means you could have the 4 different values for these random variables, right? So you can define the different random variable. Like I said, you can define any weird functions you want, right? So you can say, like, let's say here, you can define, for example, you can say the random variable y is equal to the numbers of head minus the numbers of tail. Right, you can define this one. So let's see what is the y values here, right? So y value is the number of the head minus number of the tail. So the y is 3, right? So this is 2 minus 1, so it's 1, 1. What is here? 1, right? So this is what? Tail, 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 and the head. So it's -1, -1, -1, and then -3 here. Right? So the lowercase y will be what? Will be -3, -1, 1. Okay, so it will be -3, -1, +1, and the 3, right? So that's what we mean, the random variable And that's how do we define, right? So you can define anything you are interested, right? So the random variable, we have two kinds. We have here, we have a discrete, and we also have a continuous here. Let me see, maybe I'll put it in here because I do want to use that space. Okay, so the random variable, right? So I can have two kinds. We call this a discrete, and we call it a continuous. So what do we mean the discrete, right? Like this example, I say I toss 3 coins. We have defined an x is the number of the heads, right? And so because then you know you have 0, 1, 2, 3. So it's a discrete number. So there's nothing in between, right? So then what is the continuous random variable means? So if you are interested to see, I said the height of the college students, then you can do an experiment and try to measure the height of the college students. And we know the height, the units of the height, you can always divide it into the smaller and the smaller units, right? So it's not a discrete, just 1, 2, 3, like a, like we talk about the discrete. So the continuous random variable, that means the value of your random variable can be continuous to divide it into the smaller and the smaller units. Okay, so that's what we talk about the random variables. So in the first part of this, all this random variable, we're going to focus on the discrete random variable. That means whatever the function you define, the value of that random variable is the one you can count. Right, so basically it's the one you can count. Okay, so now the next things here we're going to talk about is the probability distributions. And so I have in here, so this one's here is a probability distribution. So what is the probability distributions here, right? So now let's take a look here. Okay, so in here, let's see here. Let's see here, okay? So like, let's use our examples, okay? Okay, so let's use the examples here. We said X is the number of head, right? So the probability distribution for the discrete is kind of like a table. So on the top of here, you will write the lowercase x. That means the value of this random variable. So this is what we call the probability distribution for the random variable x here. That's the capital case, uppercase, right? Then you have we call it the probability of this random variable, probability of x. Like we talked before, for this experiment, I know I have the x is 0, 1, 2, 3, right? So this is 0, 1, 2, 3, right? So that's the possible value of what? Of the x. Now, let's take a look at the x equal to 0 is only these situations, right? Look at the green one, 0. So what is the probability? Is 1/8. Then take a look at x equal to 1. How many I have? 1, 2, 3. So what is the probability here? Is 3/8, right? And then the 2's here. How many I have here? I have 3. So it's 3/8. Then the 3 heads is 1/8. Remember that, right? So because, we say the random variable is the function, every element in the sample space. So obviously, so if you add all this px for all the x you defined, what is this one has to be? It has to be 1s, right? So this is 1/8 plus 3/8 plus 3/8 plus 1/8. So this is what is A over 8, right? So it has to be 1 here because it's covered every elements in the sample space. If you don't add up to 1, that means you're missing some elements, correct? Then of course, then the next things here, that's why, you know, the every probability here has to be what is greater than or equal to 0, right? I cannot have a probability is less than 0 here. All right, so that is what we call is a probability distribution of x here. Now let's take a look at what is the probability distribution for the y, like we just did this examples here, right? So now let's take a look here. All right, so now we use lowercase y, right? So this is lowercase y, this is py, and then this y is here, I defined, I say it's the number of the head minus number of the tail. So I know I have -3, and I have -1, I have 1, I have 3, right? So let's take a look at how many -3 I have. 1, so this is 1 over 8. How many -1? I have 1, 2, 3, so it's 3 over 8. How many 1 I have? 3 over 8 and 1 over 8, right? So if you add this together, py, what are you going to have? So it's 1 here, right? So this is how do we define the random variable. And be careful, see here, 2 properties, right? So what are the 2 properties? When you add them up, it has to be what? It has to be equal to 1. And each one of them has to be greater than 0. You cannot have the negative probability like we talked before, right? Okay, so it's a pretty it's pretty straightforward, right? Okay, let's take a look here. Let's take a look at examples here. Okay, so these examples we said, you know, I'm randomly select 2 socks here from the drawer. This drawer have 5 brown ones and 3 green ones here, right? So I want to have my random variable W is the number of the brown socks, right? Find the distribution of the random variable, okay? So the 2 socks here, right? So first things here, let's take a look at the sample spaces here. If you randomly pick the 2 socks here, you could get a what? You could have a browns, right? You can get a 2 brown. Or the first one is brown, the second one is green. Or the first one is green, the second one is brown. Then you have greens, right? Okay. And then it said W is the number of the what? The W's here is the number of the brown socks here. That means each element in the sample space, I'm going to give associated value. So what is here? This is 2, right? What is here? This is 1. What is here? This is 1. What is here? This is what? This is 0 here. All right, okay. Now I can start to work on my probability distributions here, right? So here, this is my probability distribution. Okay, so here, remember, we use the lowercase w to represent the value of the random variable. This is a probability w. So what is the w here have? W could be 0, w could be 1, w could be 2, correct? Okay, and now, you know, I need to find the probabilities here, right? Okay, so now let's take a look. What is the probability I'm going to get 2, you know, I'm going to get the 2 brown socks here, right? Okay, take a look here. Now, the 2 brown, that means the first one you pick is the brown, so it's a 5 over 8. Right, so it's a conditional probability we discussed in the previous. Then after you take 1, how many brown left? 4 left, right? So 4 over what? 4 over 7 here, correct? Okay, so now I can simplify it a little bit. So this is 1, this is 2. So the probabilities here is 5 over what? 5/14 here. So 2 brown, I have what? 2 brown, I have 5/14. Correct? Okay, so now let's take a look at this one. 1 brown, 1 green. Okay, the browns here the same way. First one is brown, so it's 5/8. Then times, after first one is a pick, you have 7 left. How many green here? So it's 3, right? So this one's here, I'm going to have 15 over what? 56. All right. And now this one's here, this is green and brown. So what is the probability? First one is green, so it's 3 times 8. Then after a socks is removed, you have a 7. Then it's brown, is what? It's 5. So what is here? It's 56/15. So now both of them is equal to 1. So what do I need to do here? I need to combine them together, right? So that's why my answers here, this will be 30/56. Well, if you simplify this a little bit, so this will be 15/28. So that's what I have my here is 15/28. All right. Now let's take a look. Green, green. So what is the green, green? You have 3/8. After you take 1, you have 7. So this is 2. So now let's simplify this a little bit. So it's 4. And so this will be 3/28, right? Okay, so this is 3/28, right? Okay, so now let's check to see. That's the easy way to check to see your math is correct or not. So now let's try to add all this probability of this random variable. Let's see, this is 3/28 plus 15/28 plus 5/14, right? So the common denominator, so this is 3 and 15/28 plus 10/28, right? Common denominator. Yeah, I got 28/28 equal to 1. Good, I know I did it correctly. Okay, so that is what is my random variables here, right? So better you can say W is equal to the number of brown socks. Okay, so this table, we call this a probability distributions, right? So these tables here, we are calling is the probability distribution, okay? Good, okay, now next. Okay, so for this problem here, so this problem said, check whether the function given by f of x equal to the x plus 2/25, x equal to the 1, 2, 3, 4, 5, serve as a probability distributions. Okay, so if serve as a probability distributions, remember we said we have 2 conditions, right? So what are the 2 conditions here? So the condition number 1, that means your f of x has to be greater than or equal to 0 for the order x. So when you substitute the x's here, obviously it's 1. So it's 3/25. So it's obvious. So this is true. So we know this is true for all the x's, right? Because if x equal to 1, so it's 1 plus 2, 25, greater than 0. X equal to 2, 2 plus 2, 25, greater than 0, right? So we know this is true. Okay, so now the condition number 2 is here. So remember, if this is a probability distribution, what is the key things we need to check? We need to check, make sure we did cover all the elements in the simple spaces. So I need to add all the f of x together. Okay, so when x equal to 1, so this is 25, 1 plus 2, right? And then plus x equal to 2, this is 25, 2 plus 2, and x equal to 3, so this is 25, 3 plus 2, and x equal to 4, so it's 4 plus 2 of 25, x is equal to 5, is 5 plus 2 of 25, and then here you will find that this is 3 plus 4, 7, this is 5, it's 12, right? 12 plus 6, this is 6, is 18. 6, 12, 18, and 18, this is 7. 7 plus 18 is 25, yes, we got it. So this is 25 over 25. So it's 1. So it is satisfied, right? So it is satisfied to define this function as the function given this one is a probability, can serve as a probability distribution for discrete random variables here. Okay, now let's take a look at the next ones here. Okay, so we want to find for what value of the k can f of x 1 minus k to the x power serve as the probability distribution functions again. So we are looking for the probability distribution function again, right? Of a random variable x equal to 0, 1, 2, da, 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 da. Okay, so now the first things here, I'm going to check the condition number 1. I know every number has to be greater than 0, right? So when the x equal to 0, then f of 0 is equal to the 1 minus k, right? So this number has to be greater than, greater than 0, right? And so that means the k has to be what? K has to be less than equal to 1, right? Okay, so this is so we know this one's here, so k has to be less than equal to 1. And also, let's take a look at how about, so if you said x equal to 1, right, so x equal to 1, so that means f of 1 equal to the 1 minus k times k here. We know this one has to be equal to 0, right? And we already know the 1 minus k has to be greater than 0, right? We already know here from so this one has to be greater than 0. So that's why this automatically applied k has to be greater than what? Greater than 0, right? So now I know this one's here, k has to be greater than equal to 0 here, okay? And so now I know combined these two, so I know the k has to be less than equal to 1 and greater than equal to 0. Okay. Okay, so now, let's take a look here, right? And so in here, when the k equal to 0, so the whole thing here is 0. So we know the k cannot be equal to 0. But anyway, let's take a look. Okay, so now the next things here, conditions here. Number 2, see here. This is the very important conditions, right? That means if I'm adding the x from 0 to what? To infinity, f of x has to be equal to 1. Okay, so now let's take a look to see this one is true or not, all right? So this is summation x equal to 0 to infinity. So this is 1 minus k to the x power, right? Okay, so k to the x power, so now you take this one, because 1 minus k has nothing to do with x, you can take this outside exponents, right? So you can take this one is outside exponents here. You want to add up this one equal to 1, correct? Okay, so what I want to show here is add up equal to 1. The first things here, I know k cannot be 0. Because if k is equal to 0, this is 0 to the power, so the whole thing will approach to 0, right? So I know in here, the k has to be greater than 0, right? So that's one thing here. Okay, so now, next thing's here, we already know k is less than 1, less than or equal to 1. So we know, like in here, take a look here, you know, like this one's here, we say this is a k to the x here, right? So what is this one's here? This is a geometric series, right? So this is, we call this a geometric series. For the geometric series, in order for the geometric series to, excuse me. So this one really is 1 plus k squared plus k cubed, right? So we know for the geometric series to be converged, everybody still remember what is the criteria? My ratios here, right? So the R's for this ones here is k. In order to be converged, what is my R has to be? R has to be less than 1. So in here, I cannot have equal to 1. So it has to be less than 1. So if this is the ratio less than 1, then in here, this one is 1 minus k. So what is this? You guys still remember, like in the calculus 2, the geometric series? So what is this one here? It's 1 minus k over 1, right? So that's why I give you what? Give you 1s here, right? So from here, I know that I'm using a geometric series. Let me write it here. So geometric series is 1 plus r squared plus r cubed, So what is the sum of it? Is 1 minus 1 over 1 minus r's here, right? So that's what we did here. So we know this is okay to be a probability distribution. So this random variable x is okay to be the probability distributions. All right, so okay, that's it for the first videos here. So the next video is a very interesting video. We're going to talk about the cumulative distributions functions here. So remember, right? So this is the probability distribution functions here. And then, you know, the probability distribution that we talk about is the tables, right? So that's the distributions here. Okay, that's it. That's it for this video. So nice to talk to you. If you like the video, please feel free to subscribe to the video. And okay, so looking forward to talk to you next for the next videos here. All right, have a good day and bye.